Hello. So today we are doing this problem called reverse linked list. So the problem just says that we get as input a linked list and we want to reverse it. And the follow-up here says that it can be reversed both iteratively and recursively. And so the problem wants us to implement it in both ways. Let's see this. Let's try to do it. So let's start first with the iterative way. So the way we are going to do that is, let's say we have linked list 1, 2, and 1 to 2 to 3 to 4. Okay, so we need a couple of pointers. So the outcome that we want is to do this, right? Just for the first two nodes. And then to have one pointing to nil, right? So that it's the tail of the list. This is the outcome we want for the first two, right? So what do we need? So we need something that points to nil so that we can attach to it. And we need something that points to the current one. And we need something that points to the next one. Let's take also if we go to the second one, which is 2, 3. 2, 3, what do we want to happen? So we want, for 2, 3, we want this. We want the pointer to be pointing like this. And we want the pointer to go also to 1, like this. But this would have already happened. And then we want to start doing that for 3, 4 also. So for this case also, what do we need? We need a pointer to 1, we need a pointer to 2, and we need a pointer to 3. So we need a pointer to, so basically that means we need a pointer to the previous one, we need a pointer to the current one, and we need a pointer to the next one. So we need a pointer to the previous one for the first iteration, and then to the current one, and to the next one. So these are the pointers that we need. Now, how can we set them up? What do we need the way to set them up? So let's see for the first case, just 1 and 2. So for that case, we need the next of 2 to be 1. And we need the current one to be, so first of all, we need the current one at that point to be 1. And then the previous to be nil, so that we can point to it. And we need the next to be 2, right? And basically, the operation that we are going to perform is setting the next of 2 to 1, right? And then setting the next of 1 to nil, right? So we need also so we need 1. So for the first actually operation, we just need 1 dot next to be null, right? We just need 1 next to be null, right? And then we need current to be 1, and then next is 2. For the second iteration, what do we need? We need pref to be 1, we need current to be 2, and we need next to be 3. And then we need to do 2 dot next to be equal to 1. Okay, so what does this mean? That this here means that the initialization step that we need to do is we need to set pref to be null, we need to set current to be the head, and we need to set next to be head dot next. And for this iteration, what does that mean? That means that we need pref to be the previous current, which is this one, which probably we should do in this iteration here. And then we need the new next to be basically the new current dot next. And then which current is basically now 2, right? So which we should have set current here to next, so that it's 2 here. And then we need next to be 3, so that's what we are doing here. And we need pref to become 2 at this point for the next iteration. So pref would be, at this point, pref would be current would be next, which is the same iteration that we did here. And the operation that we did is 2 dot next is equal to 1. So basically current dot next here would be equal to pref. We need to do that before changing pref and before changing current. And so this is basically the whole iteration, the whole the operation that we do on each iteration. So let's start this. So what we're going to do is we are going to initialize the pointers that we need. And prev is initialized to head. Current is to head, pref to none, and next to none. And we will initialize those here. So we will say while current is not null, while we are not at the end of the list, which is basically when we get here, then we need to do these iterations that we just spoke about. So that would be next will be current.next, and then current.next would be prev, and then prev would be current, and current would be next, so that we can go. So these two are for the next iteration, and this here you just to put the current, to save current here, so that we can save the next, so that we can put it here, because current.next we changed it here, so we just put a variable so that we can keep track of it and assign it to cur for the next iteration. And that's about it. Now, what should we return? We can, so maybe we can return current, but that's not what we should, because current will always be null when we get here, because that's basically the condition for exiting this while loop. So what should we return for the reversed linked list? Here we should return 4, right? And at this point, at the last iteration, we would have prev here, and we would have current here. Current is null; it doesn't hold on to anything. So what we need to return is actually previous value, which hold on to the head of the new reversed list. So basically, our result would be just a reversed list like this. And the head is 4. So we need to return that. And so to return that, we just do return prev. We can run this. Yeah, so that should be good. Let's see. Okay, so that passes. Now let's see how can we solve this problem recursively. So we just did the iterative version. Now let's see how we did recursively. So let's delete this. So for the recursive solution, what we want is we need a base case, and with the recurrence, and we need the main operation. So we need the base case, recurse, and then operation. So let's find out this. So the base case can be, so if the head is null, or it's an empty, or doesn't have like a next value, if it's just one node or empty, then we can just return that, because like reversing 1 is just 1, and reversing null is just null. So we just need to return if head is like, if not head or not head.next, then we can just return head, right? That's basically what we need to do. Now, what's the recursion that we want? So if this is the base case, so at this point when we have 2, 3, 4, what we can do is just say when at 1, just pass this part and say reverse this part. When at this here, say reverse this part. And when at 3, say reverse this part. And when we say reverse this part, which is just 4, we would get back just 4. Now we need to do the operation so that these two can go from being this to being this. So that's the operation that we need to do. And then this way, as we go up the stack, we'll do the operation that does this. And if we do it for each of them, then we'll end up with a reversed linked list. So what's the operation that we need to do here to get this? So let's say when we recurse, the 3 here would be the head. And so what we need to do is the next value. So head.next is 4. What we want is for 4.next to be, so here what we want is for 4.next to be 3. And for 3.next to be null. basically, if we do this operation here, then we will end up with, if we do this operation, we will end up with this. Basically, we'll end up with null. So null, and 3 pointing to that, and 4 pointing to that, which is what we want here. So what is 3 in this case? When this function gets called, 3 is the head. So head is 3, right? So let's just replace these values here with their like name. So the name of 3 is head. So, and the name of 4, what is 4 here? 4 is, so 3 is head. And if 3 is head, then 4 is head.next. So 4 is head.next. So head is 3, 4 is head.next. So let's just plug these values here in this here. So that means that head.next, which is 4, and then the next of that is equal to head, right? And 3, which is head.next after that, is equal to null. So this is the operation that we need to do. This is a very useful trick with pointers, is to just do it like this. Put the values in, which makes it easier to see, and then replace these values with their names. And just make sure you didn't like override a pointer, or like, so for example here, if we did head.next first, then we would, this here wouldn't make sense anymore. So you just need to think about having the operations in the right order. Now we know the operation. We know what we need to do to recurse. We know that every time we get a value, we need to recurse by saying, just calling the same function on, which is reverse list, on the rest, which is head.next. So now we have our base case, we have the recursion step, the recursion that we need to do, and we have the operation that we need after calling recurse, as we go back up the stack, basically. And so let's just plug this in. That means we need to do this, and then we need to reverse this, and we get a pointer to the reversed head. So one thing I didn't talk about is, so at the end, when what do we want to return? We should return 1. We should return this 4 here. So the problem is, as we go back up the stack, we no longer, the head changes. So it becomes 3, then it becomes 2, then it becomes 1. So we lose track of 4. So the solution to that is just, once you get to the head, hold on to this, basically, and keep giving it to the tab calls. And then at the end, just return that. And so what does that mean here? That means we'll get the reversed head here. Don't change it, just return it. Just return it. And so each function will return the head, the last node here, to its caller until the end. So we will end up returning 4. So now we'll do the operation here, which is just this. And yeah, so, and that's about it. We did the same logic that we did here: base case, recursion step, and then operation that we need to do. And that should work. Yeah, we need to do self that. Yeah, null is not like a Python thing. It's not actually. Okay, so that seems good. Okay, so that passes. That's it for now. See you next time. Bye.